Naming is one of those skills that you just absolutely must practice to get better at. So let's try that here. Here are 6 compounds to try. The first 3 you need to name from the drawing, and the second 3 you need to draw from the name. And you can see I've used the skeletal structure on some of them. You can draw them with whatever structure you'd like. You will also eventually need to memorize this information over here on the right, but for now, I'll give it to you. All right, press pause and give it a try. Now, if you want, you can go to the last slide to check your answers, but if you'd like to see me work through them, keep listening. All right, so here's our first example. Remember that our first step is to find the longest chain. And in this case, it's actually pretty straightforward. It looks like our longest chain goes right through here. Now, we could have instead chosen to do, say, this, but if the longest chain is straight, that's kind of the easiest way to deal with it. All right, so now we need to number the compound so that give our parent chain numbers, and we want the lowest numbers possible. So should we number from the left or number from the right? Well, if you look closely, this molecule is actually kind of symmetrical, so it doesn't matter. So let's number from the right, because everybody wants to number from the left, so I'm going to do it the opposite way. Right, we have 5 carbons, so this means we have a pentane, which I just spelled wrong, pentane. Now let's put our side chains on, and we have a 2-methyl and a 4-methyl, and that means these two combined are a 2,4-dimethyl. We've only got one type of side group, the methyls, so we don't have to worry about alphabetizing, so let's just put these together. 2,4 dimethyl pentane. And that's it. Here's our next example. In this case, we have the skeletal structure, but don't get confused by that. If you want, you can put little dots where all the carbons are to help you initially, but eventually you'll get used to this as you do more practice. You can see why we use the skeletal structures. It's a lot faster to draw, so I will tend to use them quite frequently. Okay, let's look for the longest chain. It seems clear that the longest chain is going to need to go down here, even though that's not straight. So let's start here, and then which way should I go? Well, there's 2 carbons in this direction, and there's 2 in this direction, so it doesn't really matter. So let's go this way. And there's our parent chain. It has 1, 2, 3, 4, 5, 6 carbons, so we know this is a hexane. Now we need to number our main chain, and to get the lowest number, we're either going to start from here or here, so it's clear we need to start from here. So things are getting messy here. Let's call this carbon 1, 2, 3, 4, 5, and 6. This is kind of handy because we only actually have one side group, and that's an ethyl. We're going to call that 3-ethyl because 3 is the location, and there's 2 carbons in that side chain, which makes it an ethyl. Good, let's put them together. 3-ethyl hexane. All right, now the last one I made a little bit more challenging, but again, we just follow the same steps. Let's look for the longest chain. Well, on this side, over here, on the left, it looks like all of those have just 1 carbon, so it doesn't really matter how we do the main chain over here. And now we have to decide, do we go down or do we keep going across? Well, down there's 1, 2, 3 carbons, and across we have 1, 2, follow the longer path, 3, 4. So that's going to be our longest path, and that's going to be our parent chain. All right, let's count the carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. That makes it a nonane. All right, let's number. I'm going to start. So obviously if we start from the right, there's not a side chain, a branch until 1, 2, 3rd carbon. On the left, the 2nd carbon has a branch. So let's number from the left and call this carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, all right, let's start doing side chains. We've got this one and this one. So that's 2-methyl, 2-methyl. Notice there's always a dash between the number and the word. Next side chain is here. That's a 4-methyl. Lots of methyls here. Now this is our next side chain. This has 1, 2, 3. That makes it a propyl. The position is 5. So it's 5 propyl. And then, oh, we have yet another methyl. All right, so we need to reduce these. Okay, so this is 2, 2, 4 trimethyl, 5 propyl, and 7 methyl. Great. Whoops, I forgot one. This is another methyl. So let's erase that. 2, 2, 4, 7 tetramethyl. Woo. Okay, so that takes care of those, and then we've got the propyl. So we need to alphabetize, and remember that we ignore the tetra. The M in methyl comes before the P in propyl. So our complete name is going to be 2, 2, 4, 7 tetramethyl 5 propyl. Oh, no dash there. Nonane. Remember, commas between numbers, dashes whenever you go between a number and a word. Again, you see it looks really complex, but it's not that hard if you just follow the method. Now let's try the other direction, going from a name to drawing the structure. Take kind of the opposite approach. You're going to want to start by drawing the parent chain and then adding on those branches. Again, you can draw this however you want. In this case, I will tend to use skeletal, but I'll skip it. For this time, I'll draw the whole structure. So butane, we're going to start by just drawing the carbons. Butane has 4 carbons, and this is saying that there is a methyl group on the 2nd carbon. Now, which side do we call the 1st carbon? It doesn't matter. Almost everyone works from the left and calls this carbon number 1 on the left, but you don't have to. You could easily call this 1, 2, 3, 4. If you can take a structure and just spin it around, that's still the same structure. You haven't changed it. So let's be rebels and put our methyl group calling this carbon number 2. All right, so that is the structure of our compound, but because we have drawn it this way, we have to put the hydrogens in. And you will quickly see why I like using the skeletal structures as you draw in all these many hydrogens. All right, and that's the structure. We also could have drawn this as 1, 2, 3, 4, right? Butane, and then 2. Our second compound is getting a little bit more complex. 3,3-dimethyl-4-ethyl-heptane. Let's start with the root, heptane. That has 7 carbons. This one I'm going to draw as a skeletal structure. 1, 2, 3, 4, 5, 6, 7. And remember, we're drawing it with angles of about 180 degrees, because if you look at a carbon chain, that's approximately what it looks like. Actually, why don't I draw it both ways? 2, 3, 4, 5, 6, 7. All right, now with the side groups. I'll be normal this time and number it from the left. 5, 6, 7. So 4-ethyl So I go over here to the 4th carbon. When we do the skeletal structures, we want to draw it, if this bend is pointing up, then we are going to draw that line going up. So, and it's an ethyl, so we need 2 lines there. Okay, so there's our 4-ethyl, and now we have a 3,3-dimethyl. So let's go to our 3rd carbon, and we're going to put 2 methyl groups off of it. And we're done. So let's draw that on our other drawing. We had 1, 2, 3, 4. There's our 4th. And we had an ethyl group. And then on 3, we have a methyl and a methyl. This is not complete. You have to draw all the hydrogens in. I'm not going to do that for you, but make sure you try it. Every carbon needs to have 4 bonds, so start drawing those hydrogens in, or learn the skeletal structures. All right, last example. 7,8-diethyl 2,3,6-trimethyl 5-propyldecane. Oh, by the way, did you notice that the previous name was wrong? I put my methyl before my ethyl. Ah, that was a mistake. I hope you noticed it. This one is correctly alphabetized: ethyl, methyl, propyl. But let's start with the decane. That is 10 carbons. And even though your longest, your parent chain, doesn't have to go in sort of a straight line, it's always the easiest to draw it that way. So I'm going to draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let's start adding the groups. I'm going to number this in tiny numbers: 3, 4, 5, 6, 7, 8, 9, 10. Whoops, I drew 1 line too many. 2, 3, 4, 5, 6, 7, 8, 9, 10. I sure did. It's good that I numbered it. Let's redo that. There we go. It's easy to make mistakes on these. All right, 5-propyl. Propyl is a group of 3 carbons in a row. So here on position 5, we're going to go 1, 2, 3. Then we've got 2,3,6-trimethyl. So on 2, we're going to draw a methyl. On 3, we're going to draw a methyl. And on 6, we're going to draw a methyl. And then 7,8-diethyl. So on position 7, we're going to draw an ethyl. And on position 8, we're going to draw an ethyl. You should also be able to draw this in the full structure, but of course we'd have to put a lot more hydrogens on there.